Okay, hi everyone. So welcome today. So let's
Hi.
start with the today class. So are you able to hear me guys properly?
Yep. Oh,
Yes,
good.
yes.
Thanks.
Yeah, we can able to hear you.
Okay, great. Just give me a second. Let me share my screen. Okay, so now I'm sharing my screen. Okay, so today we're gonna start with the basic theory of SD-WAN. Just a second. So before we starting with the SD-WAN, let's start what is WAN. So what do you mean by WAN? Why we use WAN?
Wide area network
Mm-hmm.
and this is the connection between sites.
Okay, and why we use it?
So basically, WAN is connecting to geographically separated location.
Mm-hmm. Okay, so it will provide you the connectivity for your business requirements, right? Operations. So what are the ways to connect over WAN?
MPLS broadband,
Mm-hmm. What else?
Point-to-point link.
Baseline.
Mm-hmm.
Frame relay. Ethernet. VPLS.
Frame relay Ethernet, these are protocols.
Okay.
So we have WiMAX,
Broadband.
OGLT, broadband is again internet, we can say like, right? Satellite. Okay, so see, these are some of the ways by which we can connect and use.
VPN, VPN also, no?
Sorry.
VPN also, the VPN is the same thing of internet, the VPN.
I'm not able to understand what you're saying.
The VPN is kind of one or no?
So VPN is actually over the connection you make the VPN, right? That is overlay something.
Okay.
So now how the WAN is changing in past 10 years. So what is WAN evolution? So now we have software as a service, infrastructure as a service, right? We have applications in our cloud, right? Our branches are getting direct internet access. There is a requirement to access data at any time from anywhere, right? So all these evaluations need a model which will be more robust, which will be more automatic, which will be more manageable, right? So companies start looking into that and they start focusing on the solution which will provide the more better solution to your WAN evolution. So then the SDN concept comes, and in the SDN we have. So what is SDN first of all? Do anyone knows about SDN?
It's software defined network. It's a fully automated scripting.
So scripting is a part. Okay, so I can say programmable. What else?
You're logically separating the control plane, data plane, and the management plane. And with the help of controller, you manage the network.
It should have a centralized controller.
Yes.
Okay, then the most important concept is separation of your and guys, if you have any doubt, you can ask in between. Okay, do not worry. Do not hold your doubt till the last point. So separation of your control plane from your data plane. And that is the important concept for this. Okay, so the SDN solution comes and all companies.
One quick one.
Mhm.
One quick doubt. So if here we are saying the separation of control plane and user plane or data
Mhm.
plane. So how that is happening in legacy routing? Like if you say
So in
MPLS
legacy, it is not there. No? That's why
or
this is
any.
the SDN solution. In legacy, if you see your router is handling all the three planes. That's why
Okay.
SDN came in
Okay.
picture.
So the router or the routing protocol is handling both, like
Router,
control plane and data plane.
not routing protocol. It is router or switch, which is handling data as well as control as well as management, right?
Okay.
Okay. So in SDN, they come up with the technology or concept known as SDWAN. Okay, so it is actually your SDN solution applied to your WAN environment, which makes it SD-WAN, and a lot of companies jump into it. And right now, almost every major vendor have their own SD-WAN solution. Whether you talk about Juniper, whether you talk about VMware, whether you talk about Cisco, right? Silver Peak, Fortinet, every company have it. Okay, your Versa and all that. So now we will talk about SD-WAN, how it overcome some of the challenges of the traditional WAN and what are the benefits we will get from the SD-WAN environment. But before doing that, let me tell you one thing. SD-WAN is not replacing your existing infrastructure. Okay, so whatever we wrote in our last slide, MPLS, internet, 4G connectivity as and your broadband, etc., satellite, MIMX, everything. So it never gonna replace or those things. So for running the SD-WAN, we need the underlying connectivity. So underlying connectivity is needed. And SD-WAN we run over top of that underlying connectivity. Okay. So always remember, it's not gonna replace your MPLS. It's not gonna replace your any of the other circuit, internet and all. How you can switch from MPLS to internet, that is a different situation or story. But it needs an underlying connectivity, IP reachability between your sites, between your data center and branches before starting with the SD-WAN. Okay. So anyone having any doubt on this point? All good, guys? If you are good,
Yep.
you can give the thumbs up or you can say yes so that I can move on. I usually teaches a particular topic, and then I are used to ask question like if you have any doubt, because I don't want you to hold your doubts. Okay. Okay. So our traditional WAN challenges. So what are the challenges we have in our traditional WAN environment? Can anyone tell me?
Yeah, so data flow all the way back to the data center and out again.
So basically, you can say centralized, right?
Yes.
Centralized, or I can say it here for that.
Sort of data center centric.
Okay. So but whatever traffic you need to send to the data center, that always go to the data center, right?
Yep. Yep.
So what is the challenge in that?
Not application centric. So
Mhm.
there is no application awareness.
So no application awareness,
More complex design.
complexity,
Scalability.
scalability,
Also, the security is very centralized, so mostly in the DC.
security, yes.
More administratable.
So manageability, troubleshooting, monitoring. What else?
It's cost of bandwidth.
Cost, QoS, carrier dependent, right? So these are some of the traditional WAN challenges, although we can write a lot more, right?
SDWAN also carrier dependent, right?
Sorry.
SDWAN also carrier dependent, right? That last one.
So I'm coming on the SDWAN.
Okay.
So now when we talk about SDWAN, so first of all, you have the control. Okay. You build your tunnels over your existing infrastructure. So you have your complete control over how you want to send the traffic. So it is not your carrier dependent. Okay. Then you can automatically migrate from slow to fast links at any point of time. It will automatically change. You can set your SLA. If it doesn't meet that SLA, it will migrate it between your links. Okay. Now it automatically creates IPsec tunnels. Okay. IPsec. Why we use IPsec? Can anyone tell me?
To tunnel the IP traffic for data confidentiality.
To protect for the security.
Yes.
Security for the traffic.
Security, data confidentiality. So the word I want to hear is encryption. Okay. IPsec, encrypt your data. Okay. So now you can run your data over the internet circuit as well, your critical data. So now you can easily negotiate with your MPLS service provider. Okay, if you want, you can shift your data as well. In SD-WAN, your traffic is application aware. Now, what do you mean by application aware? It is automatically having a deep packet infection, which will identify from layer 5 to 7 what type of packet is going through the circuit. And you can put your policy over that circuit, and so you can put your policy on the traffic data. Like I want, for example, voice traffic to go via MPLS. I want my web traffic to go via internet. So you can now decide over which application you want which circuit. And if in case it is not providing you the SLA or it is not meeting you SLA, then you have the control to shift your traffic automatically to the other circuit. So now you have the choice. It is easy to deploy. It has zero touch provisioning and PNP. So what do you mean by zero touch provisioning? Zero touch provisioning is your vendor will send you the box, and as soon as you plug it into the network cable, then we have a centralized controller in SD-WAN where we do all the configuration, and it replicate your configuration over the circuit, and it will ready your box within seconds. So you don't need a third party engineer or field support to configure your branch router. Okay, so it will be up within 5 minutes only. So you have the option to do the pre-built configuration. As soon as you plug your device into your circuit, it will automatically take the configuration from your centralized controller, and then it will deploy that configuration. Okay, then security point of view. So one is your IPsec tunnel, another one is your certificate-based authentication. So it will, again, all these topics we will go in very detail. Okay, so this is just the overview I am giving. So certificate-based authentication means whenever any of the device join to your SD-WAN environment, to your SD-WAN fabric, then it will do the authentication with your controller via certificate. Okay, so PKI, we can talk about all these steps. PKI, what is PKI, and CA server and all that stuff with a very basic. Okay, then scalability.
Can I ask? Okay.
Yes, Mark, tell me.
May I ask? Sorry. Okay. So, is there any pre-configuration that needs to be done on the device, the edge device, and does it connect to Vbond? I was reading a bit about it. First, would need to connect to Vbond. All these different components. I'm just trying to understand VSmart and Vbond and Vmanage and all these bits and pieces.
So yes, Mark, I'm gonna take all these components with a very scratch. So do not worry. Just wait for 2-3 days, because
Okay, thanks.
yes, I am going with the flow, and I will make sure you will get everything from scratch. Do not worry. Okay.
Thank you.
Yes. So now related to scalability, it is easily scalable. Okay. So it is very easily scalable. Even you can add up, you can go up to whatever number of sites within the thousands as well. So thousands of sites you can add very quickly. Then it is having the centralized controller, which will manage all your configuration, and from there you can manage all of your SD-WAN devices or edges. Okay, edges means your router, which is present. So SD-WAN have a different model of routers, which I will talk in a minute. So yes, you can handle all these SD-WAN devices through your centralized controller. Then you have a centralized monitoring. From a single pane of glass, you can see each and everything. Okay, and you have also centralized troubleshooting. Any site, if anything fails, you can just troubleshoot it from a single place. Then it is programmable. So you can do programming as well as automation. Okay, so these are some of the top features of SD-WAN, which makes it a solution which is right now as per our WAN environment needs. Again, we have a lot of other advantages as well. So as we move on in the course, you will get all the advantages. So anyone having any question till here? All good, guys?
Yeah, clear.
Yep.
Okay.
Yes, centralized monitoring, you mean that the edge nodes can be monitored, or the complete the customer the legacy nodes, for example routers, also can be
Nothing.
monitored.
So again, your centralized monitoring means your SD-WAN devices, not the
Edges.
legacy one. Yes.
Okay.
So now, as this is the course for Cisco SD-WAN, so we will talk about Cisco SD-WAN. Okay. So let's first talk about Cisco SD-WAN history. So previously what happened is Cisco started with the SD-WAN solution, which is known as Cisco IWAN. I hope you guys remember about this term IWAN for around 5-6 years back. They have this solution. So they started with this solution. And then there is a company known as Viptela, okay, which started their own SD-WAN solution, which is known as Viptela SD-WAN. Okay, so it is actually more robust and better solution in the market than any other vendor. So what Cisco done is they acquired this company. Okay, and then they acquired this solution and they rebranded to Cisco Viptela SD-WAN. And now they are even rebranding it to directly Cisco SD-WAN. So in now latest Cisco docs, you will find it by the name of Cisco SD-WAN. But again, in this SD-WAN solution, we have both company devices still present. So one is Cisco devices, other one is Viptela company devices. Okay, although those devices are also now of Cisco. Okay, guys. So any question till here? So I will talk about those devices and all. Okay, so now tell me guys, what are the planes we have in networking?
Control plane.
Data plane, control plane, management plane.
Okay, so control plane, management plane, what else?
Data plane.
Data plane. So what is control plane?
It's responsible for routing.
What is routing? That means only for routing?
It
So
involves
best path and policies, stuff like that.
this way policies access list, no?
So your protocols which help in maintaining the control related data, right? So your routing updates, switching updates, all that stuff. So
Does it mean that something involved with the CPU, or what is the actual definition of control plane?
So again, it doesn't mean by CPU, because again, data plane will also hike your CPU, right? So control planes means which will help in building the control topology, or you can say updates, your routing updates or your switching protocols. So for example, let me give you the example. So all your STP traffic, all of your ARP, right? Your RIP, DSCP, EIGRP traffic. So your protocol traffics, your OSPF, BGP, whatever that is there, right, etc. So all this traffic comes under the control plane. Okay.
So you can define that it is controlling the actual traffic.
So it is controlling your updates and all.
Okay.
Then what is management plane? So management plane gonna provides management of your
Access.
yes, management or access of your devices. So for example, SSH traffic, CLI, to a device. Okay, through a device. If it is through a device, then it is not management traffic. Netconf, etc. So these are your management. And then data plane is your forwarding of data, right? So your user data traffic, your server data, etc. All good, guys? Till here?
Yep, good, thanks.
Okay. So now, SD-WAN, again, it is a SDN solution, right? SDN solution means you need a controller. So it consists of your three controllers. So the first controller, or I'm just writing it over the first one. Anyways, you can write it anywhere you want. So the three controllers are vManage, VSmart, and your Vbond. Okay, so these are the three controllers present in SD-WAN environment. Okay, so let's first talk about vManage. So vManage consists of your management plane. So through this controller, you can manage all the devices. You can configure policies on the devices. So all your management related features, you can do it. Okay. It only comes in your virtual appliance. So there is no physical box. Okay, even in production, it only comes as a virtual appliance. You can download it either in the .ova file format, or you can download it in QCOW2 format. Okay, so these are the two images format in which you can download the vManage. It provides GUI and CLI. Okay, it also provides your programmatic interface through which you can program and do programming for your SD-WAN infrastructure. So programming interface via your REST API and your netconf protocol. So netconf is used to talk to your devices. Okay. Then it is the centralized controller, which will provision your devices, which will configure your devices. You, for redundancy, you can make it in the active standby state if you want. Okay, in cluster. In cluster, you can go up to 6 controllers, 6 vManage. Okay. And each vManage supports 2000 edge devices. So your 6 will support 12,000 edge devices. Okay, because one vManage supports 2000 edge device. You can do software upgrade of any of the edges or any of the controller through this one only. You can do centralized troubleshooting and centralized monitoring through this by single logging to this controller. So tell me guys if you have any question related to this.
Netconf is something like an XML, or what kind of protocol
Netconf
is
is
that?
actually a protocol which will transfer your configuration between vManage and between your edge devices. Okay. So it is used to access the device via API call behind the scene.
So is it something that it has to use SSH and then do some APIs?
Yes.
Or okay.
Yes, through SSH only. Yep.
Okay.
Okay. Anyone having any other question before we move on further? Mark, let me know.
Yes, yeah, just a very quick one. With the vManage OVA, what's the cost of those? And is it recommended that, say, a small site have 2 of them for redundancy, but what would be the cost consideration?
So related to like vManage, so again, These so cost you need to check on the Cisco portal. I'm not sure about right now current cost, what is going on. But again, for redundancy, so this is a centralized controller which will either sit in your data center or in the cloud. I will tell you in next 10 minutes where you can configure these controllers. Okay. So
Okay.
OVA is for your VM environment. You can put it either on the vCenter or VMware ESXi server or any other server like your Red Hat and all. Or QCOW2 is your KVM. So for KVM and for the lab environment, it like for the emulators also you can use this image. Okay.
Okay, got it.
Yes.
So
Uh,
basically, this vManage is hosted in a Linux environment.
So again, yes, behind the scene, it is running Linux, but not hosted. Hosting, I will tell you. Give me
Okay.
5 minutes.
Yep.
So it is a virtual appliance, right? You know about the .over files. So it is a package which will you get, which you can implement it over the different hypervisors. So I will tell you over which hypervisors you can put it. Okay, all good till here.
Other vendor also having same we manage Vbond like that only the same.
So they have the different names. Again, somehow having the 3 controllers, some having the 2 controllers. So it depends vendor to vendor. Like in Versa SDWAN, they
okay.
called as V director like that.
We can have multiple Vbonds and we manage, right?
So right now I just talked about vManage till now, right?
Right.
So vManage multiple you can set as per your for your redundancy need, and also if you are crossing a 2000 edges mark, then you need a second vManage for sure. One vManage can support up to 2000 edges.
Hi,
This
Shank.
edges means that is like we are deploying as part of SD1, right? That is not the end routers, right?
Yes, these are not normal
Or
routers. These are the devices which are running the SD-WAN code, which is different from your
okay, yeah.
traditional one. So in just 15
Okay.
minutes, I will
So
tell you
one
about these edges and all.
okay, yeah. So one
Yes,
edges may
Shank.
can control multiple devices, right?
No,
Multiple end devices
edges,
in routers.
see, edges will not control anything. These are controllers. Right now, I'm talking about controllers. Right now, I'm not talking about edges. Controllers, we have 3 controllers. Again, guys,
Okay,
these
Yes,
okay,
are
got
Shank.
it. Yeah.
these are your controllers. These are not edges.
Yes, Shank. I have a question, if you allow me.
Yes, yes, Sajid.
You mentioned that the cluster is active standby. In
Mm-hmm.
case I have six vManages.
Mm-hmm.
Only one will be active, and the other five will
Yes,
be in standby.
yes.
Okay, thank you.
Again, guys, these are your controllers, and every controller having the different role. So right now I talk about only one controller, which is vManage, which is used to manage your SD-WAN infrastructure. Okay. Again, anyone having any question or doubt?
Okay.
All clear, good. So I hope you finding me interesting that I am asking you again and again if you have doubts, because again when you see the instructors, they keep on teaching and no and it doesn't matter from them whether you are guys are understanding or not. But for me, it is not a problem. You can ask anything anytime. Even right now, if you don't have any doubt, you can ask me directly on Slack.
Sure.
Okay, so next, our second controller, which is known as VSmart. So VSmart is again your virtual appliance. There is no physical box present for VSmart, and it provides your control plane. Okay, and then it is you can deploy it if you want in the active-active. It distributes your control information. So again, what is control information? Your updates, whatever the routing updates and all. To your WAN edges. And it do it via a protocol which is known as OMP, Overlay Management Protocol. So this is again one of the protocol which they use, which will provide to and fro of your updates. Do not worry about this protocol right now. I have a whole dedicated 2 classes for this, which will give you in detail about what is OMP. Okay, so do not worry.
So Sank,
Yes.
so can you elaborate a little bit on active status?
So active means your both control planes. So if you have 2 controllers of VSmart in your environment, for example, VSmart 1, another one is VSmart 2. Okay, so both can be able to handle your control plane information. So both will be in the sync, and they can distribute the information to the devices.
Okay, thanks.
Like you have in the Nexus, you're in, if you know about VPC concept, virtual port channel. So your upstream devices, both the control planes are active, right? Okay.
So
it,
do they, do they synchronize the data between the?
yes, they synchronize the data as well.
Okay.
Okay. Then it also distributes your data plane. And control plane policies. So whatever policy you will configure, that distributes those policies to your VH routers. Or right now, do not use this word, to your edge devices. And again, guys, wherever I'm writing edge devices, that means SDWAN running code devices. Okay, so these are special devices which I'm gonna talk you in next 10 minutes. So these are not your traditional devices. Okay, so all control plane related information will be handled by your VSmart. Anyone having any question till here or related to VStar? All good, guys?
Okay.
It's all good. All good.
How many active sessions it will carry?
Sorry, Satish, what are you saying?
Many connections it will support.
Satish, your voice is breaking. I'm not able to understand anything.
How many active sections can we create? Active.
So active, I need to check the limit, but again, I guess it will be 2 only, but I need to check. Okay, right now I'm not sure about the limit it has.
Okay, thank you.
And even it is more than 2, then it can be active, right? So your control plane information can go over all the VSmarts. Okay, so now the third controller is Vbond. So it represents the orchestration plane, or also known as security plane. So the main function of Vbond is to provide the security to your SD-WAN infrastructure. And how it gonna do it? So before that, let me tell you again, this is a virtual appliance. There is no physical appliance for Vbond as well. Okay, and then it authentic. So main is feature of Vbond is to provide security. And how it gonna do? It authenticates your edge devices. So once you plug your edge device in your SD-WAN infrastructure, then they start authentication with them using certificate. Okay. And also they uses the whitelist. So again, whatever license you download before from the Cisco for your edge devices, you will get a license file. So it check against that license file whether you have a valid license for that device or not. If you not have the valid license, it will not add to your existing infrastructure. So now, for example, this is Cisco, and I brought one edge device from here. Okay. So this is one edge device I brought, and I got, for example, XXXYZ. So this is my license number. Now I can sync my Vbond or vManage through Cisco, and I can download the license file automatically from that. So my license file now having this serial number present inside it. Okay. Again, it is a combination of your serial number, JC number, all those stuff. So if it now once I plug it into my to my infrastructure, then it will try to authenticate it with this serial number, JC number. And if it is matches on my license file, then only it will allow to communicate with other. Otherwise, it will not. So if you take any other organization edge which you do not have the license, then it is useless for you. It will not work in your existing SD-WAN environment. Okay. Vbond also provide mutual authentication between your vManage, VSmart, and itself. Okay, what do you mean by this is your vManage, this is your Vbond, this is your VSmart. So you have three different controllers. So now what it's gonna do, it will try to do the mutual authentication between Vbond vManage, Vbond VSmart, and between your VSmart and vManage as well. Okay, so they all three of them authenticate each other, and they're gonna do it with the help of Vbond. Okay, your Vbond. So whatever IP address you will configure on your Vbond, that should be publicly reachable. So why the requirement of publicly reachable? Because if your edge is connected to the internet, it try to connect to your Vbond IP, okay, to authenticate itself. So it should be publicly reachable, but if it is not publicly reachable, or if you are using it behind your private IP address, your RFC 1918, right? So you need a one-to-one net. So means your static net you need to configure so that your Vbond can be reached over the internet. Okay. So I will show you how it needs to be reachable and all that stuff. So anyone having any question related to Vbond?
So Shank, I've got a question about that. Can you run that Vbond for multiple customers, or the flip side of that, does every customer need its own Vbond virtual?
So again, every customer needs, so means you are, I'm not getting your question. Means you are saying if you purchase one Vbond, can you run it for multiple customers?
Yes. So if you're a service provider, would you be able to use Vbond for multiple customers? And then if you just your own self, a customer, not a service provider, do you still need the Vbond?
So you can use it for multiple customers as well. There is a concept of VPN in SD-WAN, which we will talk in our later classes, through which you can segregate your customer traffic, and you can use your existing three controllers to do the configuration and all that stuff for every customer.
Okay, thanks. Got it.
Yeah.
So Shank, so what is this license which you talked about? So what does it contain? It contains the list of the serial numbers of the device which you purchased under the same customer account?
Yes. So every edge which we purchase, okay, edge is a physical devices. Okay. So edges are our physical devices. So every physical device we purchase, we get a serial number, chassis number, and one-time password OTP. Okay. And this, when Cisco ship it, they embedded it in a TPM chip. Okay, inside it. So they embedded that into your router and they send it to your site. Now, once you connect it and they attach that to your Cisco Smart account, right? From which you purchased it. Now, what happens is once you connect it, your Vbond will get that license file or directly serial number from your smart account because Vbond will connect to vManage. vManage will pull up or Vbond will directly pull up your license file. So that is how. And again,
Okay.
we have a lab. So I will show you how to
Okay.
connect and all.
So one more question. So this solution cannot be used in any air gap network. I mean, in a network where there is no internet access. This needs to have some internet
No,
breakout,
again,
right?
yes. If you don't have the internet access, then there is a different method. Cisco give it a offline method, which is known as your bootstrap method, where what you can do is they, if you want, they can ship it with a USB key, and then you can put that key into your edge device, and then you can run it. But again, to communicate your edge with your other edges, you need the connectivity, right?
That can be given through, the MPLS also, right? The private IP,
Yes,
which is
yes,
the
yes.
WAN network.
Doesn't matter. Doesn't matter.
Okay, so I can use it in this MPLS network as well. The
You
solution.
can use it in the MPLS as well. You can use any of the medium. It should be your end-to-end reachability you need to provide first. That
That's
is the
all.
main thing. Yes, that's it.
So this
Eh,
licensing can be sorted out with the help of that USB offline method. That's it, no?
Offline method, online method, anything you can use. Okay, so we have different methods. I will tell you about the methods in later
Thank you.
class.
Thank you.
VH device we can able to access via console, right? And locally.
Which one?
VH devices.
Yes, so any of the VH you can access locally as well, and you can access it via vManage as well. So your choice. But again, once you install it, vManage, then it is better to have a centralized management where you can directly access any of your device. Even directly in the GUI, you can open the SSH session. I will show you in the next classes how you can directly open any of the edge device CLI. Okay.
Okay, the setup never will work mixed vendor devices, right? Only
Sorry?
mixed vendor device. In Juniper, this will
No.
not. Yeah. Okay.
So right now it is only for the Cisco SDWAN devices. Okay.
The edge device can be same Cisco, but the customer which we are going to control using SDN, that can be any vendor, right?
No, not got your question. So through
So the
these
edge device,
controllers, you can only configure or control either Cisco device or Viptela devices.
yeah,
If you
as
have
a controller or the edge device.
from the controller to the edge device, if you want to control any edge device, you can control it via only the Cisco devices or Viptela devices. No other vendor device you cannot control.
Okay. Okay.
Yep. Now to host these controllers, so you have the option. You can go either via on-prem option. What is on-prem? Your premises, right? Whether it can be DC or any of the branch, you can say 99% cases it will be DC, right? So there are two options. One is on-prem, other one is in the cloud. So if you want to use on-prem, then you have vSphere ESXi hypervisor support. Okay. So over which you can use it. And also you have KVM support. where you can use .q cow2 images. So that is for on-prem. If you want to go over the cloud, you have the option to host it over Amazon AWS. You have the option to host it over Microsoft Azure. You have the option to use Google Cloud Platform, GCP. So any of these three major cloud vendors. And then fourth one is Cisco Controller as a Service, where you can take the service that is a paid service from Cisco, by which Cisco will host your controllers over the cloud, and they will manage your controller. They are responsible for any of the issues which will come in your controller. And in the backend, they use actually AWS to host your controllers. Okay, so they will take, so there is a charge that they're gonna take, and then they can manage and host your controllers over whatever cloud platform you want. Basically, they have the AWS only, so they use AWS in the backend to put it. Or you can directly take the subscription of AWS, Azure Cloud, GCP, and you can directly put your controllers over the cloud as well. So it's your choice.
So is there any way where the data security can be a breach if you host the controller on the cloud or whichever you take?
So again, if you know all these cloud vendors, so they have their security solutions as well, right? And anyways, they have a very high security mechanisms in place. But again, anything can happen anywhere. Data breach can happen on your DC as well, right?
That's true.
Yes. So again, it depends organization to organization where they want to use it.
But what kind of data can they see? Let's say if it is compromised also, the actual data is encrypted end to end, right?
And even your actual data is not going via controller. Actual data is going directly via your service provider. So your only the updates, your routing updates and all that stuff and all those things is here. Your actual data never goes via controller. That's what the SDN solution do. It decouples your control plane through the data plane.
Right.
Right? Your data is going directly. Okay. Okay, guys. So this is all related to controllers. Now let's talk about edges. So in Cisco SD-WAN, as you know, previously Cisco and Viptela combined each other, and then so there are two type of edges present. What edges means your edge routers. Okay. So one is known as C edge, and Viptela ones are known as VH. Here, this C represents Cisco and V represents Viptela. So what are the device models in C edge or Cisco having it? So that are ISR 1100, ISR 4000, ASR 1000, ANCS. Okay, so these are all the devices, and then your latest one, 8000 series as well. So these are all your physical devices. Okay, and for lab testing, it comes your virtual device as well, which is known as 1000V. So this is for your virtual, for your lab and test environment, not for actual production. Okay, so this is what comes it. Now, what code ISR runs? Can anyone tell me ISR, ASR?
iOS X.
So they
iOS
use
XE.
iOS XE. Okay, this is the iOS they use. So now what done Cisco is they not completely change the code. So whatever is the whatever the code present, they added the SD-WAN code inside it. And so that it increases the functionality. And now your same device, which is your Cisco original ISR, that is now run SD-WAN as well. Okay, so that is now capable of running SD-WAN as well. So the image is different, okay, which has the SD-WAN code added. So you need to download that image and you need to wipe off your router and you need to install this image to run SD-WAN, to run that router or your existing device into the SD-WAN environment. Okay. So this is for Cisco. Now for Viptela, vEdges have different type of models. So vEdge 100, vEdge 1000, vEdge 2000, vEdge 5000. So again, all these series are your physical appliances, means physical chassis. And then you have vEdge Cloud, which is virtual, which is again used for your lab and test environment. Okay. And they run it Viptela OS. So previously that is Viptela OS, which is different from the Cisco OS. Again, some of the similarities are there, but again, the little bit of command syntax is different. Okay. So, and nowadays what happen is this Viptela OS, you can also put on your ISR, ASR devices. Cisco is in building that functionality as well. Sanju, can you put, yeah, thank you. Okay, so anyone having any question till here? So before you ask me what is the difference between these vEdges and all. So there is a vEdge routers data sheet. You can go over this page. Okay, if you want, let me put this in the link in the chat. Okay, and there you have all the models with the data sheet of what is the difference between them. Okay, so it is having the difference in the capacity, circuit limit, bandwidth, and all that stuff. Okay, so this is a complete table which will tell you all the differences. Okay, then how much bandwidth data rate it can support. So it is up to 100 Mbps. Then increase in that, right? What are the software features that it can support and all. So you will get the complete information about it on this page. Okay, so anyone having any question till now? So now there are two things. One is your controllers, which are vManage, VSmart, Vbond. The other thing is your edge devices, which are basically routers. So again, they are divided into two different type of edge devices, C-edge and V-edge. C-edge represents the device which are from directly from Cisco, and V-edge is for Viptela edges. Okay. Although right now Viptela is also a part of Cisco only. Cisco already brought Viptela a few years back. So again, these are the physical models or families of devices, and then you have virtual as well, but virtuals only used in lab and test environment, not in the production. Okay. So here
So,
in our,
Thanks, just
yes,
a quick one. So this vManage, vSmart, and Vbond, these all are virtual appliances, isn't it?
yes, these are only virtual appliances, even in production as well.
Okay, all good. Thanks.
So now the point here is we are running the vEdge. So if you again see our topology, So if you see here, alpha site, okay, this is my headquarter. This is actually my headquarter site over which I have these three controllers. One is vManage, other one is Vbond, third one is VSmart. Okay. So these are my three controllers which are present. Guys, after speaking, just put your mic on mute. Okay, so these are my three controllers which is present. And then if you see over my sites, so these are my different sites, eta, gamma, zeta, delta, okay, and beta. These are my 5 sites. So over this, these are my edges. So if you see it over eta side, this is my VH1, VH2 on the gamma, VH1, VH2 on the zeta, I have one VH, and on the delta, I have another VH. And then if you see the beta site, which is a special site, again, this is special because I put it CSR. So this is CH, okay, which I put it here. So we will work on both the edges. I will show you the differences and all the configuration of both the edges, whether it is a V edge, whether it is a C edge, okay. And behind these edges, this is a LAN environment of every site. Okay, so we are just emulating this environment with our switches. Okay, and this site has two LAN different sites of LAN. And in middle, we have our providers, which is MPLS, internet, and 4G.
So,
Okay.
Sank, so it looks
And
like
we have,
the
yes. Mhm.
yeah. So the eta and gamma side, these one have two edge devices,
Mhm.
but the zeta one only have one.
Yes.
Is there any specific reason, or just you put it randomly?
So again, for gamma, I need to tell you one concept, which is T-lock extension. So that site is dedicated for that. For again, wherever are two devices, I will show you the differences. What happens when you have two devices? What happens when you have one device? So again, if you see the connectivity, every site is unique. Every site has a different type of connectivity. Okay, and which is by purpose I made it. So you will get the differences and all.
Yep, sure.
Just for example, let me tell you one thing. So for this site, if we talk about ETA site, okay. So ETA site has two edges. One is here, another one is here. So the LAN routes which are coming from this will go to your provider, and okay, and after that, when they come back, they're not gonna learn it here on this site. This edge, you will not see these routes, because again, your same site route should not learn via provider, right? So again, what happens behind the scenes, there is a switch over which these are connected, and then you have the routes which is learning directly. So again, I made this topology with some points kept in mind. So I will show you all these when we do the labs and all. And again, guys, we have a same Windows server, over which here on the CS server, where we generate the certificates and we will put it in our controllers. In production also, we have a Windows server. In 90% of the cases we use it. Although you can run any of the Linux server, or even you don't need any server, directly on the vManage, you can create the certificate if you want. But what happens in the production, I will show you the same way. Okay. So in production also, we have a Windows server over which we generate our certificates and put the certificates so that our edge devices and our controllers can talk and all. Okay, so that is also I will show you in the labs. Then this dotted line, this represents your direct internet access. Okay, so every scenario we will be gonna cover it in our topology. Then we have this ASA in below here as well, where we do service chaining and all. Okay, so we will try to inspect our traffic with this ASA and all. Okay, anyways, so anyone having any question till what I explained today?
That cloud one, that virtual appliance must be on same location. Must be everything Vbond, Vmanage, VSmart, or a different one is a DC, another one is in cloud.
So again, unless until you provide the connectivity, they need a connectivity between each other. Okay, if you can provide the connectivity, you can put it anywhere you want. Even you can put two in your data center, one in the cloud, anything, but they should be reachable with each other. So you should need to provide a connectivity between each other.
So let's say if we put one of those vManage in a cloud, what like how can we provide connectivity between our headquarter and cloud?
So how you provide it? This should be my question.
Yeah. So I guess one option could be through VPN. Yeah, not quite sure.
Well, VPN or internet connectivity, whatever is there, doesn't matter. Unless until they able to ping to each other, they are good. They don't have any problem.
I think, but it has to be on the same network, isn't it?
Yes.
Okay. So if it's in a cloud, obviously it will be in a different network.
No, even if it is not in the same network, that also I don't think that you're gonna get any problem.
Okay, but it has to be a public IP address.
For Vbond. For Vbond, we need a public IP. Even you can put it in the private range as well. But if you put it in the private, then you need a one-to-one net, which is your static net. Means it should be reachable via internet, Vbond.
Yeah.
Because once your edges come, they're gonna authenticate with the Vbond first. When Vbond authenticate, then it passes the control to vManage and VSmart. Again, I have a series of steps, which I will tell you what happens when the edge come. So I will tell you all that stuff. But again, your Vbond should be reachable through the internet or MPLS, whatever the circuit is.
Shank, what if the scenario is for MPLS? If we are going to deploy the SD-WAN on MPLS, okay, and we don't have internet circuits on the branches. So in this scenario, how can we provide the reachability to the Vbond and the controllers?
So again, in that case, that is simple. Then you can provide the reachability via MPLS only. You don't need it then internet connectivity.
So you mean to, for example, we locate the controllers in the data center, and we provide the reachability from the branches to the data center.
Yes. So what happens is, let me tell you, when your edge comes, first it will check for a DNS entry for ztp.cisco.com. Okay. This is in every device they embedded that. So they will check for this DNS entry. So you will point this DNS entry towards this Vbond. Okay. In case of MPLS. In case of internet, what gonna happen is they try to get it ztp.cisco.com. From there they connect it to your smart account. Then your smart account is connected to your Vbond. So your smart account will passes control towards your Vbond. So your Vbond will try then authenticate it. But in case of MPLS, what you will do, you will put a DNS entry for your Vbond, which is ztp.cisco.com, so that any of the device come, it will directly go to your Vbond infrastructure. That's it.
Okay, got it. Thank you.
Yeah. Okay, guys, any other question? Yes, William.
What did you say iOS SE was again?
Sorry?
iOS SE? I mean iOS XE?
Yes, so we have different flavors of iOS, right? iOS XE is for your ISR and ASR devices over which they are running. So we have iOS XE, iOS XR, normal iOS, Nexus OS. So these are the different type of operating system Cisco having.
Oh, okay.
Yes. Previously, they used to use the Catalyst OS, right? Right now, you don't have the Catalyst OS on any of the device. So everything is shipped on iOS. Then iOS, inside iOS, you have different flavors. iOS normal, iOS XE, iOS XR, it depends on your hardware device and your Nexus OS. Okay. Then a Nexus also runs in the Nexus mode, NXOS mode, or in ACI mode. So again, in Nexus also, we have different type of modes. So it is just the software architecture. Okay, guys. Anyone having any other question before we wrap up for today's session?
Branch side, LAN side, we are nothing changed, right? Everything is STP, VTP, our concept are same. The LAN side.
Yes, LAN side, nothing gonna change. Your LAN will connect as it is with the protocol, whatever you want to run with your VH. VH supports your OSPF, EIGRP, BGP, everything. Static routing, all that stuff. Hassan, don't
That
worry.
LAN side or
Yes.
continue. That LAN side also need to be Cisco devices, or
No,
it can be
it doesn't
any.
matter. It should support your OSPF protocol or BGP protocol at least. So any other device you can
Okay,
do.
yeah.
It has nothing to do. Everything will be controlled by your like your V controllers will handle these V edges. And after V edge, whatever you have, it doesn't matter. Hassan, you will get the workbooks. Don't worry about that. I know when to give the workbook. Okay, so do not worry. But anyways, I will provide you tomorrow morning the first part of workbook, although it is little early, but okay.
Yeah, because we already got the instructions for to access the lab, so it would be better if we can get the workbook so we can get familiarize ourselves with the lab and the environment.
Yes, yes, you can do it. But after this version and the next version, I'm gonna upload once I took the class. Because before giving the workbook, then people will lose the interest in the class. So no worries. Tomorrow morning, I will upload the first workbook in the Google Drive. You guys can check it out in the morning. So again, after around 12 to 14 hours. Okay. So thanks a lot, everyone, for joining today's session. Tomorrow we will meet it again at the same time, and we will start configuring our controllers. So I will tell you the basic interfaces, how you need to connect it, what are the configurations you need to give it on those. So basic configuration. I will start from the scratch. Okay. Initializing of your controller from the very scratch. Even I didn't put the host name as well. Okay. So do not worry. I will just gonna start it from the scratch only. Okay. Thanks a lot, everyone, for joining, and let's meet tomorrow, same time. Bye.
Thank you.
Thank you, Shanks. See you. Take care.
Thank you.
Thank you, sir.
Thank you.